Hello. All right, let's try this. Let's how to do Jamovi and multiple regression thing. So, as we talked about today and some other class periods, the first thing we're going to do is we're going to import our data into Jamovi. So you click on those three little arrows at the top, go open, click on this browse button, find your data. I have mine located here. So we're going to do multiple regression. Double click. And there it is. Sorry, it took a little bit to get there. All right, so I'm going to start from, you've already done all the data cleaning. You've looked at data entry errors, missing data. You've looked at range of scores, you looked at outliers, and you looked at normality. So we're going to start with the assumptions that really add to the multiple regression analysis. So the first assumption is your sample representative of the population? So for this one, we're looking at how does the memory, sound, picture, and concepts predict Spanish letter word recognition. We're just going to make the assumption that it does. The second thing that the second assumption that there is for this analysis is your sample size large enough? Remember, the magic number is 50 cases plus m times 8, where m equals the number of predictor variables. And so if we look here, this is our criterion variable. So this is what we're predicting, reading. We have 1, 2, 3, 4. So that would be 50 plus 4 times 8, which means we need to have 82 cases. But we don't. So we don't meet that. See, right here, we don't meet that assumption. All right. The next assumption is the level of measurement of our criterion variable. That's the reading variable right here. It needs to be interval or better. We have ratio level data, so we're good on that. The next assumption is the normal distribution of the criterion variable. Well, how do we do that? We go to Analyze, right here, Exploration, Descriptives. We're going to put reading into here, right? But then we're going to go down to Statistics, and we're going to click on Skewness and Kurtosis, right? So remember, we divide the skewness, that right there, by its error, and that number cannot be greater than 1.96. We know that's not. Same for the kurtosis, so we do have normal distribution of the criterion variable. The next thing we're going to do is we're going to look at linearity. And so how do we do linearity? Essentially, we need to run bivariate correlations. And we need to look at bivariate correlations of all the IVs, right? And how does it relate to the DV? So they need to be linearly related to the DV. So what do we do for that? We click on Regression, Correlation Matrix. We move Reading all the way into here, right? And so that produced our correlational matrix. Let's flag the significant correlations and let's hit the end. It gives us our sample size per comparison, so pairwise comparison. So a pairwise would be memory to reading or sound to memory, right? And so if we look at all these, they are all significantly correlated. So they're right there, right there, right there, and right there. So they're all less than 0.05. So we meet the assumption of linearity. Check. All right, what's the next assumption that we have to do? So the next assumption that we have to do is to check for normality of the residuals. So how do we do that? Essentially, we're going to run a regression. So we hit Regression, and this is in the Analysis tab. Hit Linear Regression. We're going to move Reading to our dependent, Memory all the way to our covariate, so memory through sound, picture, and concepts, right? So notice it just populated our regression, right? We're going to go to assumptions, and we're actually going to run normality of the residuals, homoscedasticity, and multicollinearity at the same time. It's kind of cool that we can do that. So we click on collinearity, QQ plots, and residuals. So what we're going to look at first is we can look at multicollinearity, because that's basically what it spits out first. So remember our VIF statistics right here and our tolerance statistic right here. Though the VIF has to be less than 10 and the tolerance has to be greater than 0.10. Obviously, we are violating that assumption. I think that makes sense to everybody. The other way, so that's for multicollinearity. The other part of multicollinearity is to see if our covariates, memory, sound, and picture, and concepts are related to each other, but not too related to each other. So we scroll back up. We've already run this. Here's the correlational matrix. So we don't really care about reading, so we don't care about this column right here, but we do care about this little triangle here. So when we look at sound and memory, it is 0.957. That's their R value. That's huge, right? And that's above that 0.80 number. So anything above 0.80, when you correlate one to another, they're basically measuring the same thing. So sound is so highly correlated with memory. Picture is highly correlated with memory and sound. Concepts is highly correlated with memory, sound, and picture. So when we look at all those correlations, we essentially, between the correlational matrix and the VIF statistics, we violate multicollinearity. So we don't meet that assumption in this analysis. Now, to look at normality of the residuals, we want to look at this QQ plot. That's this right here. Right, so we have this trend line, right? And we want to see all these little dots like that, and here, and here, and here, and here, and here. We want them to fit along those lines. And we don't want to see a lot of deviation. This little mark right here seems to be deviating. That little mark seems to be deviating. We have a flare here. But all in all, this is relatively a good fit on the line. So we would say we meet the normality of the residuals assumption. Now, we have to look at homoscedasticity. So that is for each of the different variables, right? So each of these, we don't want to look at fitted. We want to look at reading, memory, sound, picture, and concepts. And remember, here's our zero line. We want to see a general non-pattern. We want to see equal proportion from above the zero line and below the zero line. And we want to see kind of equal proportions between kind of the half point on this side and the half point on this side. Generally speaking, it's okay if you look through each of these. The homoscedasticity seems somewhat similar. I would definitely say that this concept one is the worst because you see a cluster over here, right here, versus a cluster right here, right? And so I would say we marginally meet the assumption of homoscedasticity. So now that we've done sample representatives, sample size, level of measurement, criteria of the criterion variable, that's your dependent variable, normal distribution of the criterion variable, that's reading, linearity, normality of the residuals, homoscedasticity, and multicollinearity, now we can run the regression. In essence, we've already run the regression. So if we go all the way back up here, there's our regression box, but we need to add a couple of more things. So we're going to close this drop-down window. We're going to go to model fit, and we want to make sure that our R squared and adjusted R squared. See how it added something right here? We want that, and we also want the overall F test. So we need to click that little checkbox right here, and notice that added our F value, our degrees of freedom, our error, and our p-value. So that all goes into your table. The other thing we need to do, so let's close the model fit, and we're going to click on model coefficients, and we want to click on the standardized estimates. Notice how that just added this. So essentially these are called standardized beta weights, and we need to know in a regression which one of the covariates is significantly predicting our reading scores. And so if we look in this column right here, we see 2 that are significant and 2 are not. The 2 that are significant are memory and sound, and the 2 that are not significant predictors are picture and concepts. And you can tell that by their t-value as well. They're really small versus these, right? Well, the beta weights, the ones that I just put over here, tells us kind of the amount of size. And so if we look at sound, right there in the middle, it's the biggest predictor. It's the biggest standardized estimate of the dependent variable or your criterion variable reading. So it's the largest predictor, followed by memory. And then picture and concepts, they do not significantly add to the model. So essentially everything is here for you to fill out your ANOVA table, your paragraph for assumptions. But how do you export this? So there's some kind of a cool function in Jamovi that I really do like, that when you click on any of these boxes, so if you double click or 2-finger click with an apple, it comes up with these little drop downs, and you have, say you click on all, so that highlights everything. You can copy it, and here's the cool thing. If you bring in a Word document, I'm going to open one up really quick here, and sorry, hold on. And then I'm going to bring your Word document over here, and I Control V, and look it, I just copied and pasted. That's pretty slick. It could help you with your homework. And it has everything that was in that output file. So that's one way to do it. The other way is if you double click, select all, and you export, you can actually save it as a PDF. So if you want to save it as a PDF, and we'll say multiple regression homework, and then I'm going to save it to my desktop and hit save. It'll actually export it as a PDF. So you can always cut and paste that. You can attach it, and I'll show you what that looks like here in a second. So if we go here, that's the homework I just opened, and it actually looks like this. Again, really slick. I think it actually exports far better than SPSS. It doesn't have the HTML function that SPSS does, but it's all there, and you can save it, and you can modify it, and you can put it into Word if you want to. So that's how you would do that. The last thing I want to show you too is how to save it. So the best thing, so you have your data file over here, right? And then you have all your analyses over here. It actually saves it as one file instead of SPSS saving it as 2 different files. So you go File, you click up here, and there's 3 lines, go Save, and then notice how it saves it as a .omv file. It'll actually save this to where if you reopen it, it will actually reopen your data, and it'll reopen your results all at the same time. So what I'm gonna do is I'm just gonna save it. I'm gonna save it to my desktop, and I'm gonna save it as a .omv file. Hit save, and then I'm gonna close completely out of it. Okay, and then I'm gonna open Jamovi again, and I'm gonna want to open, browse, go to my desktop, and see how that file right there says .omv. I'm going to open that, and voila, it's all saved. And even all my analysis and all my output files. So it's kind of cool that you can actually save both the file type, or excuse me, the data file and the output file. All right, I think that's it for now. If you have questions, please let me know. I hope this helps.